So let's begin with the webinar. Can you hear me?
Yes, perfectly.
Perfect. Good afternoon, everyone. My name is Sofia Montresor, and I am part of the team of Speedhub. I would like to welcome you to the webinar, The Role of Artificial Intelligence in the Industrial Context, Challenges and Opportunities. Before starting with the main part, I would like to quickly go through the agenda of the webinar. And as you can see, we're going to have a first part in which I4MS will be presented, and some of the funding opportunity fostered by I4MS will be presented. Then we will follow with a presentation of Speedhub and Ce.S.I, our partner for the IPER Experiment. We will continue with a speech given by Professor Farinelli on the artificial intelligence application in Industry 4.0. And in the final part of the webinar, the IPER Experiment will be presented by Angelo Merlo from Ce.S.I. The webinar will be concluded with a question and answer session. So please, if you have any question, write them in the chat or wait until the end, and we will love to answer to this question. So before we start with the webinar, I would like to say thank you to I4MS. We organize these webinars with them, in collaboration with them, and we would like to organize other webinars with them in future. Since last year, we have been a contact point for I4MS, and therefore we try to foster the uptake of ICT technologies by disseminating funding opportunity promoted by I4MS. But now I will hand the floor over to Marta Portales, who is going to talk a little bit more about I4MS.
So hello everyone, I will share my screen and do a small presentation of what we are doing in I4MS. I4MS stands for ICT Innovation for Manufacturing SMEs. So the idea is that the SMEs actually adopt technologies, and that's why we are here today. Also, two projects will present, Better Factory and also DigiBrain, which are some of the projects under the umbrella of I4MS. And they will be presenting some of the funding opportunities that you can benefit from. So I4MS has been an initiative of the European Commission for a long time now, since 2013, because one of the main constraints of manufacturing SMEs was to adopt new technologies. So that's why they created several mechanisms. So in phase 3, the idea was to have 4 different projects that focused on logistics, human-robot interactions, additive manufacturing, and in this case, until 2022, there are several projects that focus on 4 main technologies: digital twins, smart modeling. Today we will hear the voice of DigiBrain, and also human-robot interaction, in this case Better Factory and Voyex are the representatives, AI through AI Regio and Kit for SME, and Pulsate. So all of these projects are going to have open calls in which you can present your candidacy in order to be funded, and today we will have the case of DigiBrain and Better Factory. So I4MS, we do a lot of things. So one of the things is to start to collaborate with different regional ecosystems and also digital innovation hubs. And this is why we are here today. From the open calls that are opening soon, this is the calendar. I left in the chat already the email and the website of the project so that you can take a look at some of these open calls that will be soon launching. We have created a brokering system, so if you actually are an SME, are a bit lost and you don't know exactly where you have to go or which open call would be the best for you, we can help you with this process. So you just have to sign up, and I4MS will help you find the best funding opportunity for you under its program. So just very Briefly, we have also a community in which we debate about different Industry 4.0 approaches. So I wanted to just let you know about it. We have 1,700 members. Half of this community is SMEs, but there are also some public administrations, DIHs such as Speedhub. So if you want to get to know it, it's there for you. We have also created a catalog of trainings. This catalog gathers, it's a repository of different trainings that European projects have done in the field of advanced manufacturing. So I also invite you to take a look at it, because maybe you find something that might be interesting. And as Sofia presented, Speedhub is one of these network of contact points. They help us reach locally the SMEs, like the ones that you are here today, and take a look at the map in which we have the different. And just to show you a little bit, there are some success stories that are worth taking a look, and we have in the website a lot of experiments. So, for example, one of the experiments is related to 3D printed clothing, but not only. So everything that it gets manufactured and that adopts a technology presented by I4MS, there are several experiments that you can take as an example in order to see also if you are fit for this type of calls or not. Yes, and there's here another one of MIDI project. The idea is that now I will give voice to the actual protagonists. So we will start with Better Factory. So Anka, the floor is yours in order to explain the soon to open call and also what we are going to be doing.
Okay, thank you. Thank you, Marta. Just 1 second. Okay. Thank you, Marta. Hi, everyone. Nice to see you here. I'm very happy to present you today Better Factory, which is an initiative under the European Commission Horizon 2020 program. Basically, we are inviting manufacturing companies, artists, and technology suppliers to work together in order to redesign the manufacturer's product portfolio. This can be a very interesting challenge, which can end up in a collaborative experiment made up by teams of one manufacturing company, one artist, and one tech provider, and they can receive up to 200,000 euros funding. We are now in the previous step regarding the second open call, and this step consists in the individual applications, which are available from the 25th of April. The call is open from the 25th of April to the 25th of June. And this is where we are inviting individual applicants, manufacturing SMEs or mid-caps, technology suppliers, and artists to apply separately in order to have a chance to be pre-selected and join the matchmaking process, which is being supported by the Better Factory Consortium. In this matchmaking, which we enable for the pre-selected applicants, we are trying to find the best fit between a manufacturing company, a tech supplier, and an artist in order to assist them to design, create, and present the full proposal in the open call for a full proposal from consortia, which is going to be open in September this year. So at the stage of individual applications, we are inviting manufacturing companies, which can be of the type small and medium enterprises or mid-caps, artists and tech suppliers, to register and submit their application online. They will find the application form available separately for each type of applicant. And this is quite a simple process where we are asking of you to fill in information regarding your basic data, legal information, a brief description of the challenges in the case of the manufacturers, the artistic expertise in the case of the artist, and of course the technology you own in the case of the technology suppliers. After you have submitted these individual applications, you will be going through a pre-selection process, which is being done internally by the Better Factory Consortium partners. And once we have the results, we are going to communicate the outcome by email to all applicants at this stage. The pre-selected applicants, as mentioned before, will be also announced, and they are going to enter the matchmaking process in order to form that team of one SME or mid-cap, one artist, and one tech provider to submit the full proposal for the second open call in September. As I've said before, the manufacturing SMEs and mid-caps are one of the individual applicants we are inviting at this stage. And if you are one of those and you are looking to redesign your current products and services with the help of an artist or a technology supplier, you are more than welcome to apply to this open call. Again, as well, we are inviting artists willing to collaborate with the manufacturing companies and the tech suppliers in order to redesign and co-create the new products and services of the manufacturers, while the tech suppliers have their added value in the use of advanced robotics and technologies for lean, agile production in collaboration with the SMEs and artists. You will have full definition of the terms and also more details on the eligibility criteria in the guidelines available for this individual call. Okay, I'm trying. Okay, so our offer, our value proposition for you right now is to enter this individual application process in order to get a chance to form a successful consortia that will then explore new markets using digital technologies, test and develop new lean agile production technologies. The winning consortia will also get access to training to reskill staff, get business support and mentoring, and of course up to 200,000 euros in funding. I will leave a link to the main land page where you will find the individual application forms for each type of eligible applicant at this stage. And you can also find the guides and documents I mentioned before. We also have spaces. We have a help desk in the community spaces where you can address any questions you may have about this step. One important aspect that I would like to underline before I go is that this is an optional step in the process of the open call for Better Factory. You can either apply at this stage as an individual company, a manufacturing company, an artist, or a tech supplier, or you can form your own consortium outside the matchmaking that we propose through Better Factory partners. The idea of the matchmaking is that you get support in elaborating the full proposal and submitting it in the open call. However, it is not mandatory, and you can always, if you apply and are rejected at this stage, or if you decide not to apply, you can always apply in September for the full proposal. Thank you very much. If you have any questions, I will be around. Thank you, Marta.
Thank you so much, Anka. And now we will go to DigiBrain. So, Andreas, the floor is yours. You're muted.
So thank you, and I will share now my screen. So I hope you see it right now.
Perfect.
Okay, so then, welcome to everybody and welcome to my small presentation. It's about the DigiBrain project, which is a funded project by the European Commission. And I'm the leader, I'm the work package leader for communication and outreach in DigiBrain, and all information and everything which I will present today, you will also find it on our website, digitbrain.eu. So in a nutshell, so our project is dealing with an evolution of the concept of a digital twin, because we like to expand the digital twin technology with analysis and decision support capabilities, means that we will add to the digital twin a digital brain, which takes up the recordings, which will offer the basis for data analysis. And the main challenge which we like to tackle is to enable customized industrial products and to facilitate cost-effective, distributed and localized production for manufacturing SMEs. And yeah, so what we offer, except from funding. So the Digit Brain project is has a predecessor project. This was called Cloudifactoring and already mentioned also in Marta's presentation. And beside our experiments, we are creating a collaboration platform. And the collaboration platform is the Agora workspace. You see the logo on the here on the slide. And Agora workspace will be operated by my company in the future, and it will be launched during the Hannover Fair. So this is quite interesting because it's a collaborative platform where you can find tools and services around simulation, optimization with simulation, and digital twin technologies. And on the right side, you will see the graphic how the marketplace and the community is organized. But I do not have the time to go into the details right now. So our open call, your chance to get funding, what we are looking for. We are looking for small consortia, mainly consistent out of a manufacturing company, so SME or a mid-cap company, together with a technology provider, and also maybe guided by consultants or an RTO. But the core of this means that we have a manufacturing company on one side and the technology providers and the consultancies on the other side, and together they are building or creates a small consortia, and together they can apply to up to 100K per experiment. But let's start with our last open call. So our last open call was happened last year, and here you see the results of it. And at least here you see the regional distribution. So a lot of companies came from Italy, but also from Spain and Hungary, and also, as you see, from other European companies. So, and we funded at least in the last open call from last year, at least 7 experiments. And also this year, we are looking also again for 7 experiments to be funded. So, and our project timeline and the red box shows you where we are current. So we are just in our open call, which started more or less 1 month ago and will last until 21st of May. So there are 2 months time to prepare your application. So it makes sense to have a look on this. And after the summertime, it will be clear which experiment, which proposal will be funded. So here our current timeline. So the open call is running from end of February until end of May. Then we have the evaluation phase from the 1st of June until the 13th of September. And then from the 1st of October this year until end of September next year, there is the time for the experiments to do their work and to execute and evaluate their outcome. So, and the proposal submission deadline, again, it's the 31st of May, 5 p.m. So, but it's not only, so as a mini consortia, you are not alone. So we also have at least 6 digital innovation hubs, which co-works with you. And if you are thinking of writing a proposal, my suggestion to you would be, please first select your DIH, get in contact with them, collaborate with them, get help from them, because we just put them into our experiment as guidance, as a support for your mini consortia. So how does it work? Let's get into the Digit Brain open calls. This picture you will find on our webpage. And there are some must-read documents which are listed here. For example, the guide for applicants, the proposal template itself, the short tech document, and other documents which are needed to prepare a successful application. And again, if you have any questions about this, and please prepare you before asking your questions, get in contact with the DIH or get in contact with us. We will help you along the way to prepare a successful proposal. So steps to follow until the 31st May. So you're the applicants. First of all, get in contact with your respective DIH. And then go into the way of the proposal preparation. And the DIHs and technical core partners will support you. And then on the funding box website, but this is also noted on our website, you find the proposal submission channel. And yeah, that's it, more or less from our side. So get prepared for this. We will also organize a second open call webinar in the next weeks. So please get into our news, register on our newsletter list or get in contact with us on LinkedIn or on other channels to be aware of this. Additional, you will find also the recording of our first open call webinar on our website. There you can listen how the workshop went. It's about one and a half hour material to follow. And I think this would be quite interesting, and you are welcome with your application. Thank you. That's all from my side.
Thank you so much for the presentation, and also thank you, Sofia and Speedhub, for inviting I4MS to present. Now we will hear about success cases and a keynote. And yeah, Sofia, the floor is yours. Thank you for having us today.
Okay, thank you, Marta. I will share my screen once again. Okay. Okay, can you see the presentation?
Yes.
Yeah.
Okay. I will quickly introduce myself once more for those of you who arrived a little bit late. I am Sofia Montresor, and I'm part of the team of Speedhub. I will quickly show you what we're going to talk about in the next following minutes. I will give a brief presentation of the story of Speedhub, and then I will present you what are our activities and what we do. And the final part of this presentation is going to be about the project in which Speedhub is involved. So let's move on with the first part of the presentation. So Speedhub is a digital innovation hub and a no-profit foundation, which is located in northeast of Italy. And due to its location and the economic history of the territory, it has a strong connection with the logistics sectors, the agri-food sector, and the health sectors. In fact, in Verona, where Speedhub is located, there are several of the leading companies in this sector. But Speedhub was established in 2017 thanks to the national program Industry 4.0 promoted by the Italian Ministry of Economic Development. And it was established by Confindustria Verona, which is the main association representing manufacturing and service companies in the province of Verona. Because of that, it allows Speedhub to be part of the Confindustria Digital Innovation Hub. But also Speedhub is part of the Veneto Region Industry 4.0 network. Speedhub in the last 5 years has been working on expanding its network, not only on the local level, but also to the international level. Now it's part of the I4MS network, DIH-WORLD network, DIH for CPS network, DigiLogic network, and also it is part of the Veneto region network of European Digital Innovation Hub, which is called Neural. Let's move on with the services. In fact, Speedhub in the last 5 years has not only been working on expanding its network, but also it has been trying to offer new services. I would like to start pointing out which is the aim of Speedhub. Speedhub as a digital innovation hub support the digital transformation and technological innovation of companies. And our value proposition could be present as a roadmap composed by 6 steps, as you can see in the picture here. We have the first step, which is the awareness. We aspire and we try to increase the awareness about innovation and new technologies. And we do that through concrete actions, such as the organization of webinars, events, or moments in which the company can share the best practices. But also we try to increase the awareness about the opportunities and the benefits of adopting digital products. Finally, we try to increase the awareness through the creation of communication content, such as the creation of videos, interviews, in which we interview experts on a specific technology, or the creation of dedicated newsletters. As a second step of our roadmap, we have the consultancy. Speedhub offers consultancies, tailor-made consultancies on issues or topics that concern the process innovation, and our methods is strongly influenced by the open innovation and design thinking. The third step of our value proposition is the assessment. For all those companies that don't know which one could be the exact solution or the exact technology to innovate their processes, Speedhub offers different assessments on, for example, process maturity level, logistic and warehouse efficiency, or employees' digital skills, or more on cybersecurity level. We think it's important for the company to understand which is their starting point in order to discuss a to-be scenario and to give them advices on which kind of technology or solution to implement in their processes. The first step of our value proposition concerns the technologies, and by that I mean that Speedhub provides to company the access to technologies by helping them to find the best partner, or providing them the access to facility where they can experiment the technologies. And some of these facilities are, for example, competence centers or demo lab. For example, we have a partnership with the ICE Lab, who the Professor Farinelli is going to talk about a little bit more in depth. And let's move on to the fifth step of our roadmap, the skills. Speedhub offers in partnership with Cime Firm, the training agency of Confindustria Verona, the possibility for companies to have the access to a catalog of courses to implement or to upskill or reskill the skills of their employees. And as a final step of our roadmap, we have the projects. Speedhub provides help or support to those companies who wants to implement research and innovation projects. Speedhub offers support that is both financial and technical. So I have finished my part of presentation. I will hand the floor over to Mario, who is Mario Spano, who is going to talk a little bit more about the project in which Speedhub is involved.
Thank you, Sofia, and good morning, everyone. I hope you can hear me clearly. With my speech, I would like to present some projects on which Speedhub has focused on the recent years. The first two involved Speedhub as technical partner in regional innovative networks, which are networks that combine SMEs and large companies with the university department, with the aim to proposing technological innovation project in certain business process or sectors. The two networks are Tech for Life, which refers to the healthcare sector, and Rivelo, which instead operates on the topics of logistics. In the first case, so Tech for Life, innovative project will be considered concerning the application of digital technologies to the medical sector, not only for companies that produce goods and services, but also for hospital or similar structure that need reliable information in real time and a safe data protection systems due to the sensitive data they process. Regarding the second regional innovative network, so Rivelo, several experimental development and industrial research projects have already been launched. Some examples are concerning the traceability using, for example, the blockchain technology to guarantee transactions and procurement along the supply chain, or the use of artificial intelligence algorithms for the optimization of routing for transportation planning, and the use of simulation technologies for the training of warehouses operators and the study of goods handling flows in the virtual environments. So Speedhub interest in technological application in the logistics sector is strongly conditioned by the presence in the province of Verona of numerous logistics operators and companies that exchange goods on the A22 highway, so north-south direction, and on the A4 highway, so east-west direction, which intersect exactly in Verona. So linked to this topic, there are two more projects carried out at international level in which Speedhub participates. The first one is DigiLogic. Is a project concerning the improvement of the development of the last mile logistics in Africa. In this case, Speedhub participated in the roundtable discussion to define a strategic partnership between European and African digital innovation hubs with the aim to stimulate innovation in the logistic industry with the goal of sharing methods and approach for the deployment of digital solution and fostering the growth of both big companies, for example, in large-scale movements of goods by air, sea, and land, or, I don't know, value-added services such as an intelligent management of warehouses and assembly, as well as in small and micro business active in last mile delivery to remote areas. As part of the 3 years project, the adoption of emerging technologies such as cloud computing, big data analysis, virtual and augmented reality, machine learning and IoT, and other systems to develop a smart logistics solution and activating a two-way know-how transfer process between Europe and Africa. Recently, we started to work on the project Logino, which won the second open call launched by DIH for CPS, an European initiative for fostering DIH for the increasing of the use of cyber physical systems in European SMEs, with the aim of helping European enterprises overcome innovation obstacles. So with this project, Speedhubs want to increase the awareness on the CPS technologies in its networks and applied more specifically on the logistics sector. And this will keep us involved until the end of this year. I would like to talk about other two projects which are aimed on the adoption of specific technologies in SMEs. In particular, Change to Twin refers to the application of digital twin to a process or a product. In this case, the role of Speedhubs, which is an accredited DH for the provision of the Change to Twin assessment tool, was to assess the level of digital maturity of the company that participated in the call with us, and then to define different operational strategies for the implementation of this digital twin. So starting from the sensors necessary to detect information and data in the field, passing through the infrastructure needed for the transmission of this data in the cloud, or up to the simulation models able to make predictions. So for example, for the maintenance or the optimization of the production process. So in conclusion, the last but not least project I would like to talk about is IPER, an experiment designed to develop a prediction model for woodworking machines. And this project carried out under the open call launched last year from DIH-WORLD. So this European initiative aims to accelerate the uptake of advanced digital technology by European manufacturing SMEs in all sectors by supporting them in building sustainable, competitive advantages and so reaching global markets. The project IPER was presented by Speedhub in collaboration with the SME Ce.S.I. Throughout the duration of the project, Speedhub contributed to the experiment, providing support in model requirements and assessment to Ce.S.I. and disseminating the experiment, providing a broad visibility through its channel. So now I will hand the floor over to Angelo Merlo, R&D manager at Ce.S.I., who is going to briefly present the SME he works for. Angelo?
Yes, you can put the...
Yes.
Okay, thank you. So next one. So Ce.S.I. is a SMEs focused on engineering in 4 business areas that are machinery, machine tool, advanced material, transport, and microtechnology. We provided service like product design or advanced engineering, CE simulation, mechatronic analysis, and in the last years, also we was involved in predictive analytics, data mining, and Industry 4.0 activity. And finally, we have also some manufacturing and prototyping activity in the case our customer, for example, want to see some design of their product in life, and then to test, to make some tests and so on. Of course, we have not series production, just a small prototyping. Our competence are in engineering, machine tool, mechanical engineering, manufacturing processes, advanced simulations, and artificial intelligence, machine learning for anomaly prediction, anomaly detection. Okay, next one. So this is just a picture that show our main customer worldwide. We work for a lot of company, a lot of brands, very famous in the field of manufacturing equipment. So not just Italy, but all around the world, or especially around Europe. Okay, next one. We are also involved in several research projects financed by the European Commission, like, in the 7th framework project and Horizon 2020. And you see here some example of our projects. So we are also very active in research and development. Okay, I just want to finish here because most of my presentation will be related to the application of artificial intelligence within the project IPER to show you real cases. Okay, thank you.
Thank you, Angelo. I would like to introduce the next speaker, Professor Alessandro Farinelli, who is the Director of Informatics Department. Okay, so please. Okay, we can see your presentation. Oh, I can't hear you.
Yes, I confirm. Professor, we cannot hear you. No.
I confirm we can't hear you.
Okay, can you hear me?
Yes, yes, no, yeah.
Okay, can you hear me clearly or?
Yes,
Yes.
clearly.
Okay, and you can see the presentation, correct?
Yeah.
Okay, very good. So I think we can start now. Okay, sorry for the small technical problem. My name is Alessandro Farinelli. I'm a full professor at the University of Verona, Department of Computer Science, and I'm also, since October, I'm also the director of the department. And what I will be presenting today is an overview, really, of possible applications of AI to Industry 4.0, presenting what are the challenges, what we can achieve with AI, but also what are the issues and the barriers that we need to overcome if we want AI to be really spreaded in the I4.0 world and to be accessible also by SMEs. So by all the presentations that have been done up to now, it's quite clear that AI is now a well-established technology for building on which we need to build if we want to realize the dream of Industry 4.0. So I thought that an interesting thing to do would be to start with looking at where artificial intelligence really comes from and what is typically intended with the term artificial intelligence. So just a little bit of history, if you want. So artificial intelligence is a term that has been used for the first time in the 50s, more or less, and probably you all know this guy, which is Alan Turing. And he was the first one to have this concept of having machines that actually can think. And this is a brief snapshot of the article that was published in 1950, Computing Machinery and Intelligence, where he was exactly asking this question, can machines think? And probably you also know the famous imitation game, which is this idea that a system can be considered intelligent if it can fool, so to say, a human interrogator. So if the human interrogator does not know if it is interacting with a human or with an AI system. So essentially the idea is a machine is intelligent if it can resemble humans, the human way of thinking. Later, in 56, very close, same years more or less, this is where really for the first time the term artificial intelligence was used, and it was for a research project in the Dartmouth school, where the idea is a little bit different and is really the basic idea of what AI is now, if you want, the modern AI, which is the idea to make machines solve kind of problems that are now reserved for humans and also improve themselves. So improve themselves essentially is related to learning and adapt to the different situation that you see in the environment. But here the interesting thing is that now artificial intelligence, the way the term is used here is to have machines that does not necessarily think in the same way as a human would think, but can solve complex tasks that are reserved to human. And this is essentially the modern interpretation of artificial intelligence, at least from the engineering point of view, which is what we care about, at least for this presentation, which is the fact that you can have machines that solve problems that requires what we think human level intelligence. So here you can see some interesting example. Autonomous cars is a very famous one. So this in the last 10 years, so to say, there has been incredible impressive advancement in this area, and this is obviously a complex task that typically needs human intelligence, but that can now be achieved and solved even in some conditions, okay, can be solved by machines. So that's a very good example of artificial intelligence. Other examples are, for example, robot playing football. So I don't know how many of you know the RoboCup initiative. Is an interesting initiative that is pushing AI towards the goal of having autonomous robots playing football. This is in the bottom left, you can see probably a system which is probably known to many of you, is the Amazon Kiva system. And essentially these are small robots that can transport pods in a warehouse. So it's a very good example of robotics applied to indoor logistics. And this also has been, we will talk about this a little bit more later, so I won't say more than this for now. The other area where recently, especially with reinforcement learning and deep reinforcement learning, AI systems achieved human level intelligence are games. So this is the very famous Go, where in 2015 an artificial system beat the world champion. And then the Atari video games, which is probably less known, but it's very interesting, where an AI system can play various types of Atari games, achieving scores which are higher than human on average. So these are all interesting application of AI in different fields. Some of these are very related to Industry 4.0, some are less. But what is the role of AI for Industry 4.0? I think this is an important point to make, because robotics and let's say computer science has been used in industry forever, so to say. So if you want, you could think of autonomous robotics cells since the 70s and 80s. You can see a picture here. So these are clearly automatic system, if you want, that can do complex tasks. Then in 2000s, there has been this Kiva system that has been used by Amazon. And now, so if we follow the evolution of time, now we see this type of robots being used, not very much, not very well spread, but they are used in some industries, which are collaborative mobile robots. So essentially, if you look from left to right, what I think it's interesting to see is that what is increasing is the level of flexibility. So if you go from the 80s, you have an isolated cell where the robotic arms were doing very specific tasks, very fast, very precise, but very specific. So no change in the task that they need to do. In 2000s, you have these robots going around in an area which is still highly engineered and designed for robots, but at least they were sharing the operative space together with other robots and humans. And now the real interest towards Industry 4.0 is to use this kind of systems, not only robotics, but also robotics, in cooperation with human, which is the next step where a lot of the effort have been directed. And clearly what you can see is that there is an increase in flexibility, in the sense that the machines needs to understand and act in environments which are open. They are not highly engineered. So this is why you need more AI, because AI is really crucial when you need to work in non-nominal condition and to adapt. The system needs to adapt to what it perceives from the environment. This is really the big role of AI. What is the value of AI for Industry 4.0? Here I'm trying to, let's say, give an overview on two main axes. One is related more to data analysis, and many examples has been already given by previous talks and probably also from the next one. The other one is for autonomy. So if we focus on data analysis, essentially the value that AI can give is the fact that you can have an automatic system that can process huge amount of data. And what you really are interested in is the fact that this huge amount of data can be compacted. At the end, data analysis is a sort of filtering operation where you extract information from data. This is what you really want to achieve. And on this, the value of AI, I think, is quite clear. So there are a lot of projects where you actually are trying to use AI for this scope. Here I'm giving you some specific examples, so to give some more context. So, for example, these are all projects that in which the computer science department has been involved at different roles. And so this is also an interesting overview on how there is a possible collaboration between the computer science department, or in general from the university, and SMEs, or in general industry. So in this first example here, which is called prediction, so the task is that you want to predict something. In this case, we are talking about district heating network. So there is a network that is providing heat to different houses. And the idea is that you want to predict the load, so the requested load from the different houses, so to regulate production. This was a project that was developed with the PowerFES investments, and University of Verona was part of the project. It was a bigger project called GOTEM, but our focus was to try to predict, using statistical machine learning and AI tools, the load request in the next 48 hours based on things that you can easily measure or easily predict. So weather condition, but also, which is very interesting, social aspects, such as if this is a weekend, if it's a working day, and so on. This is just an example, so I will not go into the detail. If you want, I can provide more information. Also, remaining on prediction, but on a different idea, is the idea of providing some sort of virtual sensors. So in this case, this is a joint project initiative. So it's a project that is co-founded between the University of Verona and a specific company, in this case, Giordano Controls. And this project was focused on residential heating. And the idea is to have an intelligent heating system that can somehow measure the CO2 produced by the heating system. CO2, of course, is very important to consider, also for a regulatory reason, but it's very costly to measure. So typically, you cannot afford to put a precise sensors inside the heating system. You only have a very unprecise sensors, which is really measure unitization. And our idea here was to derive CO2 from the sensors that you typically have inside a heating system. And this is possible using various types of artificial intelligence methods and also statistical machine learning. And so this is also another interesting idea where you decrease cost and acquire the same information without using a costly sensor. In the bottom left, what you can see is another application that has been mentioned also from the previous talk, which is anomaly detection. So the idea is to detect anomalies in the system behavior. The interesting thing is that if you use some specific AI tools or machine learning, if you want, you can do this in a data-driven fashion, which means you don't need a precise model of the system, but you can derive the model by looking at the data that you have, which is really a flexible and powerful way of doing anomaly detection. In this specific case, what I'm showing is actually some of the results of a European project called InCatch 2020. And in this case, the anomaly is interesting because it's not on a specific function or on a specific sensor of the system, but it's on the overall behavior. So in this case, we had a water drone, so a small boat, autonomous boat, that needed to follow this path that you can see here. But really what the drone was doing is to follow this path. So it's not wrong, it was going up and down, but you can see it was tilting a little bit to the right, and it was very unclear why this was happening. With the data-driven anomaly detection, you can detect this situation and then try to understand what is the problem. The interesting thing of being data-driven is that you don't need examples of the wrong behavior. You just can train your system with example of the behavior that you would like to achieve, and then detect if the behavior is not the correct one. And so you can signal an alert and then intervene if needed. So this is for what concerns data analysis. if we move on to autonomy and decision making, which is the other big role that AI can have for Industry 4.0, here obviously you have, let's say, more complex system because you need actuation as well. So you need to make decision or support decision making of a human operator. In this case, you can have robotic systems that can perform some operations for you. We will have a look at this in a more detail later on. Or you can have cyber-physical systems in general. So in this case, for example, this project is also an ongoing project, again in the POR-FESR funding scheme, where the idea is to have a system that can control air quality by performing sanitization when needed. And the new interesting idea in this project is to use AI to adapt the system to the feature of the building, which are very difficult to predict. So, for example, how many people enter the buildings, whether the windows are open or closed, if it's hot outside or not, and so on. So all these characteristics can change over time, can be difficult to predict. So if you can adapt, and this goes back to what we said before, that one of the main things of AI is to be able to adapt to new situation. You can use actually in this case a specific type of machine learning, which is called reinforcement learning, to adapt the control to the specific scenarios and so achieve better efficiency without having to precisely calibrate your system for every environment. As I said, one thing that is interesting to keep in mind is that the use of AI in the world of Industry 4.0 manufacturing in general is not easy. There are several barriers and challenges. Most of these barriers and challenges are actually addressed also by I4MS and by Speedhub, so we are on the same line, so to say. And main things are based on what I've seen in this area is the lack of availability of technical expertise, because this is a world that is changing very fast in terms of methodology and algorithms. So it's very difficult to have the technical expertise in-house to do what you would like to do. Another big problem is the interoperability of the different devices and machines. So typically in a production environment, you have machines that may be produced by different providers, talk different languages. Interoperability should not be given for granted. And this comes to the third point, which probably for modern AI is one of the biggest challenge when you talk about Industry 4.0, is the availability of reliable and high quality data, because a lot of these machine learning algorithms are based on data, but having a lot of data is easy, but having a high quality and reliable data is not so easy. So you need to consider specific platforms and specific data collection methodology to have this. Another important point is, of course, that you need a significant investment up front, and this may be not available for standard SMEs. This is particularly true for the Italian ecosystem, where typically you have small SMEs that cannot have a very big investment up front. The last point is a very interesting point also for the, let's say, methodological point of view, which is the trust in the AI methods, and so the transparency, especially for the decision making. I will come back to this point later on, because it's not only in a trust in the fact that the system will work, but to understand what the system is doing. So to our part as a computer science University of Verona, to try to partially address these challenges is actually to the establishment of this ICE lab that I will describe in a second. And this ICE lab has been mentioned before by the presentation of Speedhub, and is a laboratory. It stands for Industrial Computer Engineering Laboratory, where the idea is to have a lab that can be a middle ground between what is performed in the research and innovation side, so university, and what is actually needed by the companies that needs high TRL solutions, and also need to test the solution in a close to real environment. So this is the Industrial Computer Engineering Lab has been realized as a part of the Dipartimenti di Eccellenza project, which is a project that was awarded to the Computer Science Department of Verona in 2018. it was a significant investment. One of the main results is the ICE lab. There is a strong connection with the companies in different type of, so many companies, more than 40, are part of the Industrial Advisory Board. Speedhub is also a specific partnership with us. These companies operate in different aspects of production, so industrial automation, software, robotics, and so on. And the most interesting thing is that the idea of the ICE lab is the making available to companies the testing of new technology, the possibility of doing innovation projects, and also training. So this is the location of the ICE lab, which is quite convenient because it's in Verona and is in the area of the ex-Magazzini Generali. It's close to the train station and is quite a significant amount of space that we devoted to the lab. This is what is present at the moment in the lab. So the lab was started in 2018. It was the project ends this year, and I will show you some parts of the system working in operation in a couple of movies. And essentially, I will not go through all the different technologies, but there are various types of technology, among which mobile robots, fixed robotic system, a mini pallet transport line, an automated parts storage, and so on. The important thing is that all these components are not research products. They are products that can be and are actually typically used by companies. That can be both in the market that are used by companies. And so this is the idea that you can actually test something in a close to real production system. One thing that we focused on in the development of the lab and of the technology is a specific case study where the idea is to have the production, the assembly, better say, of a specific object from start to end, where the project goes in different phases. In the following movie, I will show you some of these phases, but essentially the idea is to have a small gadget, so to say, that contains an electronic circuits that has some sort of connectivities and can be detected by the system. The idea is that these different parts, these three parts, are assembled by the system by following a recipe that is designed at the beginning by the human, and also that this object is specific, so it contains essentially the name of a user. And so towards the end of the production phase, the user can be actually recognized because it will shake the object. So this will, let's say, activate the gadget. And through vision, we can recognize the shaking gesture and assign the user to the name. And so then you know where the user is inside the system as well. This is, let's say, a case study, so it's not a real production, but is to show all the possibilities of the different technologies. And one big part of this demo or case study is the use of these collaborative mobile robots, which are called RB Kairos. And these are two mobile bases with manipulator arms on top of the mobile bases. They have several type of sensors which they can perceive the environment, and they can essentially do pickup and transportation tasks, which are crucial for indoor logistics. So this is a movie where I can show to you, just one second, part of the system in operation. You can see here the mobile basis is going to fetch the object. This is one of the parts that will be assembled together, is actually the top cover. What you can see is that this is the automated storage system. This is the robot that is picking up the object, and then it will transport the object to the assembly station. One interesting thing that I would like you to notice is that this text that you see here during the demo, so in this case, move base to conveyor bay 5, is not just a description, but is what the designer should write, okay? This is the text that the designer should write, is the recipe, if you want, and this will be directly transformed into a plan for the robots to follow, that then will be followed in automation. Okay, so this is also interesting to see that you can give high-level indications to the system, and then the system will take care of all the rest. Okay, so in this case, you could see that the part has been removed from the conveyor belt. Then the second part will be detected and picked up by the system. And as you can see, the primitive is very compact. So it says pick the bottom cover. And then the artificial intelligence role here is to transform this to actually down to commands to the motors, so that the system can actually is able to do this. Once again, the robot now aligns with the transportation system, so it will put the object on the transportation system. And the interesting part is also, you don't see this in this video, is also that if some of these actions don't go as they should, the system is able to detect this and reschedule the operations, so to make sure that then at the end we have a successful operation. The last part is a cooperation between these two robots, which is the Yumi from ABB and then the KUKA robot. And in this case, there is the final part where the KUKA robot will actually place the screws into the different holes and complete the production of the object. So as I said, obviously, this is not a system that can be used for production, but it's just to show the different parts of the system in operation. And the most important part is the fact that this is an autonomous system can perform several tasks in complete automation. This is another interesting movie where, let me go a little bit faster here. Where here you can see two robots moving together in a shared space. This movie is interesting mainly because, so essentially the interesting part here is that the robots can find out which route to follow to avoid conflicts between them. And they're doing a pick-up and delivery. In this case, the human plays the object, the robot is just transporting the object. As you can see now, there is an obstacle that was not present before. You can see this with the annex on the topological graph. And now you've seen that the red robot moved away from the previous point to leave the other robot pass. So this is an interesting behavior, is a complex behavior to achieve, and also comes back to the concept of trust. So in this case, the system should be able to explain why the red robot moved away from the goal. If the system should say, I moved away because I have the other robot to go through. If this is possible, then you have trust in the system because you understand what the system is doing. Okay, this is was a brief overview of where are we with the development of at least the robotics part of the ICE lab. There is much more, of course, but I cannot go into the detail of everything. The current focus is a transition toward Industry 5.0. This is a new trend and a recent, let's say, relatively new name, where essentially the idea is to involve the human in the production loop much more than what you've seen now. And this has to do as well also with virtual reality, augmented reality, and so on. Just to conclude the talk, what I said before is that one problem, one barrier to the development of AI in Industry 4.0 is also the lack of technical expertise. Obviously, we are a university, so we are also providing education and training. And what you see here is a scheme of the different degrees that we are now offering in the computer science department. As you can see, there are many. The ones that are more related to Industry 4.0 and AI are the one signed here. So there is a bachelor degree that started last year, 2021, which is called Human-Centered Medical System Engineering. So this is an engineering degree. In 2020, there was the opening of this master degree called Robotics and Smart Industries, which is really focused on developing technologies for Industry 4.0. And next year, so actually 2022 is because it's the academic year is 22-23, so in October, then we start a new master degree in AI, which is more general, so to say, with respect to robotics and smart industries, and focused really on AI techniques, focusing on the two lines that I mentioned before, so perception, data analysis, decision, and support system to, let's say, address the full spectrum on the value of AI for society in general, but Industry 4.0 in particular. Okay, this was the end for my talk. So thank you very much. These are the contacts, and this is the link for the ICE Lab. In case you want to know more, be more than happy to provide more details. Thank you very much.
Thank you, Professor Farinelli. It was a very interesting presentation. I would like now to introduce the next speaker, which is who is Angelo Merlo, our Research and Development Manager at Ce.S.I. So, Angelo, you can now share your screen.
Okay, you can hear me?
Yes, we can hear you.
Okay. Thank you very much, Sofia, for kindly introducing. So I'm talking about in my presentation an IPER project that is an IPER experiment under the DIH-WORLD that we carried out in cooperation with Speedhub, as already mentioned before. This is an application of artificial intelligence and machine learning in the field that is not so popular, because you know artificial intelligence is much more in manufacturing for anomaly detection, predictive maintenance, or robotics, as you have seen. But here we have applied artificial intelligence in the design phase of the product to support designer. I will be more precise later on. Okay, so what we want to do is to predict which are the structural performance of the machine. Here a machine tool is not just woodworking machine, but in general our tool can be applied also for milling machine, drilling machine, for steel, aluminium, or plastics machining, not just wood, but wood of course are in. So starting from design specification of the machine, like size, masses of some component use, payloads, and something like that, we want to perform apply such a data-driven approach based on artificial intelligence to predict such a performance that are very, very important for the designer to understand if the machine works well or not in the production environment. So which is the state of the art? The state of the art is that the performance of the machine that are, for example, sorry, I apologize if I use some technical word, but the most, let's say, important feature for performance that the designer has to assess are the stiffness of the machine and the first, let's say, the first modal frequency. The stiffness, because as much as stiffer the machine, as much the quality of the workpiece that you machine is higher. And the same for vibration, much more higher the first modal frequency, much more better you have the machine perform in practice. Today, such a parameter are simulated using the so-called finite element analysis tools or high fidelity tools. And it takes a lot of time to model the complete machines, because you have to create a model, a finite element model, very detailed in order to be able to predict such a characteristics. Okay, so in this graph, you see in the top part of the slide in red, which is the workflow today, starting from the CAD model and design parameter like I see masses, strokes, and other things of the machine. The designer or the engineer simulate using such a high fidelity finite element tools and look at the output, the stiffness, the model frequency, and then see if it's okay, otherwise make some modification and rerun the simulation until the results are okay, and then they proceed toward the final design and they start to build the machine. What we want to do, okay, this is a very time-consuming and expensive procedure, because it takes weeks to do it, because the model of the machine is not simple to do it. So we are talking about weeks. What we want to do is to have a surrogate model, so a model based on AI that has been trained and that is able to correlate design parameters to the performance, so the stiffness or the model frequency we see. There's such a surrogate model that is a black box model, so it's very, very fast, very, very quick to run. So we're talking about minutes, not to train and to deploy. And then, so we are able in the first design phases to compare to a different solution until we find some optimal one. And the end, for the optimal one, we also have a confirmation applying the final element simulation, but just to confirm it, and then proceed to the final design. So IPER want to proceed with the workflow that you see in the bottom part of this slide in the blue color. Okay. So you see here, we want to start from some input variable that can be some input variable that characterize the machine. This is the so-called design parameters. Can be categorical, and can be numeric, like stroke, masses, and other. The output variable, as I said, are the stiffness, as I mentioned before, and the model frequency. For categorical, I mean, for example, architecture, we have several configurations of machine that designers know very well. From family, we have milling, high-speed cutting milling, boring, or other drives. We can specify if we have rotary motors with ball screw, rack and pinion, or linear motor. So are not only numerical, the variable, of course. So starting from input, we want to find a model that correlate input with output. To do that, we have to train an artificial intelligence model, starting from which are our database. The database are all the results that we have collected in the past regarding simulation, because in the past we performed real simulation. So we feed our model with input and the result of simulation, and so we train our surrogate model. So the important is to have simulation in the past, no? Because otherwise the model cannot be trained. Sorry. Okay, so we apply two kinds of supervised, what we call supervised learning. One is to predict, because we know the result. One is to predict the classes or the value range of performance, and the other to predict the point value. What I mean, the class prediction means that we are not so precise, we just have an indication. So class, for example, class 1 of stiffness KX1 is between 5.0, 15.0 Newton microns. The class KX2 is between 15 and 20, and so on. This is just to give a range. A point value prediction is of course is more precise. You want to predict the exact value of the stiffness as a function of the design parameter you use as an input. So this is the two kind of approach. For class prediction, we apply some of the methods that are known in the literature, that are the fit-for artificial neural network with multi-layer perceptron, random forest, naive Bayes, and decision tree. This is a so-called classification method. Of course, our tool apply all the method and select the best one, the one that provide the higher accuracy. That is the ratio between right prediction over the total prediction. For point value prediction, we use regression models, numerical regression models. And here you see the example that, okay, it's always artificial neural networks, random forest regression, polynomial regression, and gradient boosted tree regression. Also here, the let's say, the tool, find the optimal model, which is the one that maximize the R square, that is the coefficient of correlation, and the MAEP, that means absolute error percentage of the model. So this is a sort of KPIs that are used to maximize the performance of the model and select the most performer one. Okay, we also implemented a so-called automatic feature selection loop, because, as you know, the feature are the design parameters, the input variable. We have several input variables, no, in the machine, categorical and numerical, but not all that what we selected at the beginning can be suitable. So that means can be directly correlated with the output. So our loop make a forward approach or backward, depending on the kind of analysis we perform. But basically, if it's backward, we start with all the feature and we remove one, and the forward we started with one by one, adding the feature by one, and at the end the tool identify the optimal one, that are the one that maximize the minimum feature, that maximize the R square coefficient of the mean absolute percentage error. So this is a very important tool, because to find the optimal feature is really important. Okay, let's see how we have proceeded. We have developed two modules. One is called Learner, that are more dedicated for data scientists. That is the tool that where the algorithm will be developed and trained. And the predictor module. The predictor is for engineers. So the predictor use the algorithms that are generated by the Learner module, and will be applied to the new machine to predict the performance, instead of using, as I said, the fine element analysis and simulation. We start to train the model. As I said, we start with a database of past results that we ingested inside the Learner module. We apply the different model, and we find the optimal model. So we generate the optimal algorithms that will be sent and share with the predictor module to perform the analysis. This is a modular approach. It's very appreciated, because sometimes the mechanical engineer that want to use such a module does not much about data science and artificial intelligence. They want just to apply, put that inside the data and predict the performance. Okay, what here I'm going to show a live demo, very short, because we have time constraint. We used what is called the Knine Analytics Platform software. This is a predictive analytics platform for machine learning and data mining. What is important? There is two things. One is a free and open source. So the tools, it's open source. It's a very well known. It can compete against other very important tools like IBM Watson Analytics, Google Analytics, Amazon, and others. So it's very performing. And the other important feature is that it's that require very minimal programming. They use a so-called Lego of analytics concept. So you start from nodes, block, and you put together block instead of programming. Each block perform a specific function, like for connection to database, pre-processing, filtering, applying some algorithms related to artificial intelligence, and so on. So the programming is very minimized, so can be used also from medium range engineer in the field of data science. Okay, I move to the live demo before to show the final result. So here is the environment. You see, I don't want to explain the tool, but you see that some of the block, this is the learner workflow, where we start importing, for example, the past result, where we have all the variable, and some are not known because we have a lot of data. Some other no. So we also apply some filtering, adjusting of past data, and then import it. Then we have a correct, okay, you see here the filter data where we remove the missing value. We apply some rule where there is some missing value and so on. We import a lot of data in the past that are the input variable, and then also we add the output. So the stiffness I know because are from the simulation one. And here we generate, this is as I said, is supervised learning. And here, for example, you see where we apply decision tree, random forest, artificial neural network, and it's not programming. For example, you see here for the artificial neural network, you see that you have just to, put the number of other layer, for example, the number of neurons. So it's a very, very user-friendly user interface in order to set the parameter that you want. Okay, this is, I don't do too much inside the detail. This is the learner model. As I said, the data scientist has to prepare such a module, even if as I said, the tool is very, very easy to understand and to be learning in very a few days. Okay, I move to the deployment one. Okay, this is the tool where the engineer start to, for example, to start the analysis. You see just the I create a web interface where, okay, summarize the characteristic of the tool. You see machine data import. You can select if insert data of the new machine that you are designed manually, and there is interfaces in the here I will show, or you can import from a file. You prepare a file where you insert the input variable. You have a short also overview of what are the performance of the trained model that was trained with the historical data. So you see that, for example, for class prediction, the best model was random forest with 94% of accuracy, so very high. Also for KIPS, for frequency. For the point prediction, this is for class. For the point, you see the R square related to KX. So if you don't retain acceptable, you can retrain the model. But to retrain the model, you should be sure that you have included other past historical data for training. Otherwise, if you have not new, you should rely on this trained model. Okay, so after that, the engineer can start to select insert the feature, the machine family. You see if a boring machine, milling machine. Okay, if the architecture, as I said, a categorical value. So it's important that the algorithm is not only for numerical one, but work also for categorical and input. So here, for example, gantry machine is what you see. If we change, you can refresh and see the different architecture of the machine. So, and you can proceed. The engineer can insert what are the new machine that he is designed in this moment. Machine configuration, 3 axes on the tool or 2 axes on the. This is a specific for the designer. I don't expect that everybody can understand here, but kinematic chain, you have rotary motors, bell screw, rack pinion, linear motor, and so on. And you can insert, you can go on and insert all data. Also here, for example, the type of guider, roller, sphere, hydrostatic, and so on. And you can go on. I don't want you to bore too much. The other things you can do is to import by the file. So if you import by the file everything, you should prepare a file like this one, where you include your data in the file. Maybe you have designed several machines, and so you can just not only one, you can put data for different machines you are designing. And at the end, what happened, that the tool, I show you some testing that we have done. And here the result. You see, for example, here, the actual value, what is calculated by simulations and by practical tests, and the prediction. And this is the class actual and the prediction of class. Let's have a look to the point. So you see that it's very close. The error is very, very small. There is, of course, I would like to keep my foot on the earth, not not to go to the moon directly, but you see there is some machine that have an error. You see the red point, that means that error is over the 30%. Okay, there is some machine that happen, but most of the machine we have analyzed with data-driven model, see the error range is around, the mean absolute error is around 12%. So this is a good one. You can see here in the graph, the comparison between the blue is the actual and the orange is the predicted one. So it's very, very close, apart some here in the higher class where that means the higher value of stiffness, there is some problem. But for the other, where, for example, woodworking machine rank inside such a class is because the stiffness of woodworking machine are in the low range, and so it performed very, very, very well. This is an example for KX, and can be same result we obtained for all the other. So this is just to show the applications. I go back to my presentation. So in synthesis, you can see here what we have seen. The results are very, very, very good. Both for example, KX, also the modal frequency. As I said, there is some machine that the actual value, what it has been measured or simulated by final element, is not so close to the prediction, but could happen because there is some new machine that has some characteristic that has not been considered into the training of the algorithms, but most of them are very, very close. So for example, in the early stage of machine, you can use when you have just a rough design, no, the final one. So as I said, the conclusion, the data-driven enable a quick analysis to predict performance of the machine tool, especially in the early stage. It takes around minute, 10, 15 minutes training, generate the algorithms and apply, as you have seen. So here is a graph. For example, if you compare in the quadrant, in the x-axis, we have the total analysis time. Final element, it takes a lot of time. On the other hand, the accuracy, so the confidence of the prediction is high because FEM tools are very well proven tools that are used in engineering since a lot of years in every field, not in machine tool, in transport, and so on. IPER, the data-driven approach, AI-based, the time is very, very short. Instead of weeks, we are talking about minutes. The accuracy, okay, is not bad. It's not so high as a FEA, but acceptable in our opinion, especially in the early stage. So, as I said, early stage where you have to compare a solution, where engineer have to decide which is the best one to go on. Okay, you can apply, and you the accuracy or the confidence of the prediction is acceptable and can save a lot of time of iteration. When you have focalized your choice, okay, you can perform a final FEA final element analysis just for confirmation. So that is very, very important result that we got. Okay, the tool is ready, has been, as I said, ready, it's working, and now we want to promote such an approach. Finally, other relevant info for the project IPER you can find in the website, the newsletter, and the experiment flyer, and post on LinkedIn. Mainly the vault for everything are all the site of DIH-WORLD or the Speedhub website where I find what I've shown here. Okay, to the conclusion of my presentations. Thanks a lot.
Thank you, Angelo. Can I have two questions for you. The first one is earlier we saw the data you used to build the predictive model. But my question is there a minimum set of information or data that for a good accuracy of and reliability of prediction?
Yes, this is a good question, Mario. As I said, you have to start from past simulation, past result to train the model, like happen in every machine learning tool. You start with data. This is a supervised model, so we should know input and output variable in the training phase. At least here, if you want high prediction, we have start at least 50 use cases, from 50 to 100 use cases that we have in our database. That is the minimum one. So it's a lot of number of simulation we perform. Is not, we are engineering company, so our work is to make simulation, to make design. But I think in the company that also the customer that produce the machine, that design the machine, have its own engineer that has performed simulation. So you have to start from past data.
Okay, thank you, I get it. And the last one is in terms of service for enterprises, how could the model be used by companies?
Okay. One important key issue is that the cost of the platform, there is no cost for it's open source. So it can, if you want to apply the model, you can download the platform. There is a lot of tutorials. The company, the software provider is very, very skilled in providing instruction and so on, and courses and so on. It's an open source. What you need, it is our service is to, okay, is the platform like a software. You have to include your algorithms, your workflow, because it's an open box. No, we as a service we can support the company to develop the workflow, its own workflow that is able to predict machine performance. So supporting developing. Once we have developed such a workflow, the customer can populate with its own data and apply, and that's it. When they have the workflow built in such a tools, so we can, after that we can support in the case they need to have some suggestions. But just at the beginning, it's a one-time supporting, developing the workflow, and then they can apply themselves.
Okay, thank you, Angelo.
Okay.
Thank you, Angelo, for your presentation. I would like to invite the public to ask questions if they have them about the funding opportunities, or if you have any question to ask to Professor Farinelli or to Angelo, please feel free to write them in the chat or to unmute yourself and ask the question. I only would like to say that I'm having technical issues, so I cannot see the chat.
So there's no questions in the chat.
Thank you, Marta. So if there are no questions, I would like to, is there a question? No? Okay. So if there are no other questions, I would like to thank you all the speakers and that participated to this webinar. And if you have any other questions or anything else that you want to know in depth, feel free to contact Speedhub. Our email is fondazionespeedhub at confindustria.vr.it. So feel free to contact us and we will share the questions with the speaker. Okay, thanks to everyone. See you.
Thank you.
Thank you. Goodbye.
Bye-bye.
Thank you.
Thank you very much, everyone. Bye. Thank you.
Bye-bye.